Germany in 2017, and you were giving a
Maybe.
keynote at a conference, Reconf. So that's when I got aware of you.
Oh my goodness.
Yeah.
Wow. Yes. Well, I do remember that was an amazing point in my life for many reasons. Fantastic. So that's when we met. I'm grateful for it.
Anyway, and so I think again, like everybody who is pushing in that direction, everybody who's a thought leader should be aware of who else is just pushing this topic and trying to make it seen. And so that's kind of the state I wanted to set.
I love it, Michael. I love it. Yes. Let's see if we can attract even more of a community from like-minded authors, thinkers, doers. Um, and I don't know if I'm that skillful at marketing, but if I am, I don't know if I am, then maybe it'll help people who want to find each other and put more momentum behind these more modern ideas of design, build, manufacturing, test in hardware. Well, Michael, if you're okay, I'd actually like to start with a story, which is the Wikispeed story, which you've heard in a keynote, a version of, but I'd like to connect it to what I'm doing now. If you don't mind, I think this might be the best way for our audience to understand who this Joe Justice guy is and
Go
why
for
he
it.
gets to talk to Michael right now.
Perfect.
In 2006, I fulfilled my dream at the time. I started a car company. That's what I wanted to do. And I'd wanted to do it for a long time. I used Agile methods to execute it with Agile methods. And these photos are all actual photos from the builds. Each Thursday morning, it started out with just me, but it eventually grew to 4,000 people in 23 countries. So this company did scale, Wikispeed did scale. Each Thursday morning, we would draw a new car in CAD as a 3D model. Just like software, some simple pieces of software can be coded in a morning. And now with AI agents, even some very complicated pieces of software can be coded and tested in a morning. But you can definitely draw a 3D drawing of the exterior shape, the aerodynamic shape of a car in a morning. Then a big machine would cut that car out of foam, and it takes about an hour. And it's a life-size piece of foam. Thursday night, we would wrap the foam in carbon fiber. Carbon fiber is a lot like a carpet. It depends on what thickness you get, but it's often very thin. And you drape it over and wet it with epoxy, or sometimes it's already impregnated with epoxy. And because it's wet, it sticks like a swimsuit. It sticks onto the foam even. And we would put plastic wrap and Vaseline under the foam so it could come off later. We'd do that every Thursday night. Then Friday, we would go to car shows to attract customers. And this is a photo at the largest car show in the world at that time. The Detroit Auto Show was the largest auto show in the world at that time. And we had booth space between Ford and Chevrolet, like as if we were a real company. We would track how many interview requests we would receive to judge how attractive the new car design might be. Inside the car were reusable modules of aluminum boxes. Each Thursday, we would improve each module and build a new car. Each Monday, we would complete all government testing for a new car. Now, this is where many people first start to become really surprised. They're used to the idea of government testing for a life-critical road legal system like an automobile to take 12 months, 18 months, and cost tens to hundreds of millions of euro. In our case, we found the government labs themselves to run the tests directly were about $200 a session, and we would book every week in advance. So we would book, here's emissions testing. We'd simply schedule it every Monday during a time slot that worked for them, that was typically empty for them. And we'd pay the $200 directly, not through a consulting company or a road legalization specialist consulting company is typically how most big manufacturers do it. By booking directly with the test labs directly, it was very affordable and we could do it every week. We would crash test or simulate crash testing every week. That let us always obtain road legal approval. And every week we would produce a new design. This set 4 world records, and Agile hardware was born. Then I went to work at Tesla. I'd been making 1 car a week for years in my own company in Wikispeed, and many people asked, can this work in mass manufacturing? And I would say, I'm sure it can, but I actually don't know. And then I was given the chance. I was told my interview at Tesla was the best interview they ever had. They never asked me what school I went to. They never asked me who I knew. They just asked me very technical questions about how to work with aluminum, how to manage suppliers, how to ensure road legality when you're building car parts. And I was familiar with that type of information because I was actually doing it every week. And that is exactly the type of employee they said they wanted. And what I've discovered since working at Tesla and mass manufacturing is what I do now. Now, instead of just having a presentation, we should now have a conversation. So, you know, where I am, where I came from. The first thing people get stuck on, usually, when I talk about agile hardware or fast iterating hardware, is they think physically changing the shape of metal or plastic or circuit boards takes months. Some people think software has to take months too, but there's examples where Amazon releases an update to their web services about once a second. Some fast-moving app companies test and release multiple times a day. Well, hardware, actually cutting some aluminum to make a mold for mass production, and then doing mass production, spraying plastic into that mold, actually takes just a few seconds. The actual moving metal, glass, plastic around really takes just a few seconds. That's the speed of these tools, whether the tools are used by hand or by machines. So the real slowdown is the same slowdown software agilists have been curing for decades. Handoffs between teams, not cross-functional teams, contracts waiting for review, suppliers on the other side of the world with offset time zones, perfectly offset time zones, suppliers with a queue of different companies ahead of you, and the solutions are the same. If we wanted to make a new headlight for a car and we wanted to make it today, just like you might want to make a new piece of software today, we would need a team that can design, build, test, including road legalization tests, and manufacture a headlight. That's the recipe. It's just like extreme programming brings pairing, and then mob development brings group work, especially with AI assistants. If you have a group of people, either remote online together, camera on, working on one thing at once, or even better, at one table together, looking at a big screen or passing a laptop around, they can draw CAD, edit the CAD, machine the metal molds. Really, that takes minutes. Do the release treatment. It's chemical pastes that go on the molds, spray in the correct materials, especially if they have it in stock, pull parts. If they actually have test expertise there, they can do the required optical testing and government required testing. They can do accelerated aging and use existing aging analysis on those same materials. Hopefully they have that catalog already. And they can actually approve and sell cars with that new headlight in a day. And as a Tesla employee, that's what I did every single day. That then relaunched a consulting career for me. So now I am in Japan working with Toyota. I do also work with Honda and a tiny bit with Nissan. I consult to the leadership team in Mercedes-Benz in Europe. Then also some Chinese-owned companies. Like Jaguar Land Rover is now Chinese-owned. And I have had some interaction with them. Then Volvo Cars is Chinese-owned, and I've had interaction with them. And actually a little bit with Ferrari. That's a whole other topic. Then aerospace and banking, but that's much more broad. The common thread is, how do we have something new and useful deployed today? And interestingly, in hardware, it's exactly the same recipe as software agilists have been implementing for decades. Co-located cross-functional teams, or if they're remote, at least not multitasking, they're all working on one thing, have all the expertise to solve your problem end to end in team, and heavy use of automated testing. With AI agents is even easier. We can say, agents, create my automated tests and iterate this CAD model until all tests pass, and then download it into the machine to machine the mold, and let me know when the machine passes tolerance tests, when the mold passes tolerance tests to your CAD. And that can be done before coffee break. Michael, your book coming out, Product Velocity, has been built on conversations we've had since back in 2017, and many, many more. What is interesting to you about the fact that companies like Toyota are trying to shorten hardware development life cycles now, or SpaceX and Tesla are becoming infamous for shortened hardware life cycles?
Yeah, it's nice to get a question from you to turn the whole thing around. First of all, that was like a great introduction, and I think really set the scene very well for what we need to excel at, and especially also in Europe to compete. So that's great. And before answering your question, just to quickly circle back, it's very interesting because I just want to let everybody reflect on the pictures you showed, like seeing like that huge old monitor standing next to the car. I remember when we still had um, those old heavy. I've even forgot the technology name for that.
CRT
Yes,
tubes is what we
exactly.
called them in American
Yeah,
English.
and
I don't know about German or German English.
and I think it's interesting what you were saying about building street legal cars in a week 20 years ago. I mean, if we could do that 20 years ago, I mean, what can we do today with 3D printing, with AI, with all those technologies? And just, circling back on that, I had a conversation, and that was just weeks ago, of an automotive engineer who basically said, "Oh yeah, that Joe Justice, he does those cars, but we can do that too. We have like our OEM workshops, and they can build a prototype car in a day or two. But it's so different from doing it in production." And so this is what I find very interesting, especially I believe that you have like a super interesting approach to, I think, having like components test themselves, which totally reminds me of what we do with unit tests and integrated packages in the software world. Um, so, I mean, two answers and responses to what you were saying. So, number one is that you still get a lot of objections based on, yeah, what you can do in a workshop or in the maker scene is not the same that you can do in production. That's different. And the second question, basically along the lines of, yeah, I mean, you can do that with rocket science, with car companies, with billions of investments, but we are just building, a complex medical device or this or that, and the world is different. So those are the two primary objections that I hear. How would you respond to
Hmm.
that?
The objections actually, I think, really come from, there's something that person is not allowed to change that prevents them from doing it.
Hmm.
I think that's the actual objection. So if you have someone who's in procurement and they're not allowed to change the overall project lifecycle and product lifecycle, they can change aspects of procurement, but they're not able to change the design upfront approval process before procurement gets permission to start. For example, they're not able to change the vendor selection policy after an initial procurement selection phase.
Hmm.
They will then need to say something like, We are different. We can't do it. And I think that's a really polite way of saying they don't have the permission to change what's required to change. Clearly, it's possible. Companies do it. Neuralink makes new and human embeddable medical devices every 45 minutes. New, approved by the US FDA. So clearly, it's possible. So where do these objections come from? I think it's a symptom of what is slowing down these companies, which is divided authority, and not divided by product, but divided by skill set. So most companies around the world took on something that became really popular in the US in the 1980s, Sloan silos, skills-based management
Yeah,
structure.
yeah.
And it has an advantage. There's a reason it became so popular all around the world, is it's much easier to manage a group of people that only do accounting. The
Not just that, not
head,
just that. I mean, like when I think about Sloan, I mean, that was like the early 20th century. We didn't have the complexity. A car was complicated, but not complex. And complicated systems, I think I would argue you can very well design that way and build that way. But now we have exploding complexity. We have so much innovation, and those mechanisms break down. Would you agree or disagree with that?
I think it's true, but I think it masks another point that's also important. So I agree, and it's slow no matter what. Even if we're working on a complicated and not a complex system, like maybe a 1980s car,
Mhm.
it still is a multi-year cycle. And if we want to go quickly, whether it's complicated, complex, or chaotic, that system will never execute quickly. It can't. That's the nature of, that's the fundamental exchange of a Sloan silo, is you have a handoff system and a wait for approval system. And people closer to the work that take on more execution roles have to push up requests for a decision and wait for it to come back. And it's a waiting based system.
Mhm.
So even in a complicated system, which yes, it can function and it has functions, it's still slow. Then I think I understand where you're going with this though. In a more complicated, in a complex or chaotic system, it ceases to function entirely,
Yeah,
which
exactly.
I think is part of why if we look in a Porsche Taycan, an electric Porsche, the electric parts don't say Porsche, they say Rimac.
Hmm.
Porsche says, well, this isn't a 1980s 911 anymore. We have these high-tech motor controllers, battery pack cooling systems. Let's outsource all of that because our current systems, our Sloan silos, are incapable of not even slowly completing these complex systems, but ever completing these complex systems, which I think is part of the point you're making.
And if
And
you're
I think
outsourcing,
that, go
oh,
ahead.
sorry, go
Sorry.
ahead. So no, I'm just saying, like, if you're outsourcing, then you certainly cannot achieve the speed that you're talking about.
There are some suppliers that are incredibly quick, but then they won't be quick with your input. They'll be quick with what they already know. So that means you've just set a time bomb for when they're going to replace you.
Yeah. And that's basically where that's the direction I wanted to go. And I mean, buzzword here is Conway's law. You need structures that reflect the way you work. And I mean, that's what I've seen in your approach of basically building teams that can act very quickly and are optimized for what they're building. So so I personally I think that product architecture and organizational architecture, they are so strongly connected. And this is like, I think the biggest problem in legacy car makers, that they have an organizational architecture that doesn't reflect the requirements for the product architecture anymore. So the question along those lines would be, um, what kind of product architecture makes this possible in the first place? And before you answer that, one thing that I rarely see in your work is talk about platforms. But if I look at companies like BYD and XPeng, they're or Xiaomi especially. I mean, they learned from building smartphones. Platform is everything, and platforms makes it possible to accommodate software and hardware speeds. Do you agree? Do you disagree? What's your point of view on architecture and platforms?
So I think if we use a very specific definition of platform, we're all talking the same thing and it works.
What's your
I'll
definition?
try to share an image again.
Hmm.
Tesla has shared some great images of how they divide their company and how they divide their product, but I don't have any right in front of me right
Hmm.
now. For those interested watching this later, feel free to Google, or Michael, if you want to edit and insert some, that's absolutely fine. Here's an
Yeah.
older image from Wikispeed, and it's incredibly similar. I first consulted to Tesla in 2010 on what became the Model S. It was then called White Star. And my recommendation was more independent modules, more pieces that can change and the rest of the structure doesn't have to change. And I'll call those modules. You could use a specific definition of platform and also call them platforms. But there's other ways that you can perfectly correctly use platform that doesn't mean what I'm talking about. What's important is, in my understanding, is a structure that minimizes weighting, a structure that doesn't weight.
Hmm.
If we have a platform for self-driving and we can change that to a different platform for self-driving, and the wheels don't have to change, the suspension don't have to change, the battery pack doesn't have to change, the seats don't have to change, then that is also an independent module that works. But if we have a platform for noise, vibration, and harshness that is reinvented for each shape of car and each wheelbase and each tire size, that's not what I'm talking about. That then has to wait on what tire size are we having, and that waits on how heavy is the battery pack, and that waits on what's the wheelbase, and et cetera, et cetera. That's a design that maximizes weighting. So when I say module, what I'm attempting to say is a design that doesn't weight. The components are more, or luckily completely independent from each other. And those type of platforms are the future. And those are the companies that are becoming very successful. You can incorporate their designs without redesigning between their versions. So for example, if a company did lease or purchase Tesla's full self-driving system, that can incorporate in a series of cameras without changing the battery pack of the customer's car, without changing the seats, without changing the steering wheel, without even changing the display in the car. It integrates into a truck, a backhoe, a London taxi, a school bus. It'll integrate regardless. So you could call that a platform, but it is also a design that doesn't weight, a module. When I split the Wikispeed car, that was my one goal, trying to make these sections more independent. And that is what I recommended to the Tesla Model S, which did then adopt it. And Tesla has increased the level of independence between the modules and more modules ever since, which, to your point about Conway's law, has let them reorganize the company to better match the product modules. So in Wikispeed, we would have the drivetrain module group, and they could upgrade and update the drivetrain module without the seats having to change, without the interior module having to change, without the chassis having to change, without the suspension even having to change, which most people actually think the suspension would have to change. Interestingly, it doesn't, but that's a more nerdy, longer conversation. And Tesla does exactly the same thing, and SpaceX does exactly the same thing. But most companies don't. Most companies integrate because that matches their Sloan silo structure. They have the leadership team, then the design review, noise, vibration, and harshness operates as an audit that has permission to disrupt the other teams at any time. Safety as well, cost reduction as well. And then ultimately, most of the work, the engineering work and the production work and the validation work, is pushed out on suppliers, which are simply asked for the lowest possible bid. So that is a model that minimizes innovation and maximizes the time it takes for any change. So platforms are fantastic if they minimize waiting, because
Mhm.
you can change platform version without redesigning the rest of the product.
I have one comment and one follow-up question. So the one comment is, yeah, I agree with the weighting, and I'm sure you're familiar with Don Reinertsen's work. And he introduced like this one metric, which I find extremely powerful, the cost of delay. That is a great metric for measuring whether you're successful or not, because it's economic and you can really even apply it on things like technical debt and so forth. When I was talking about platform, and that's why I think it's so interesting that Xiaomi is so successful in building cars. I mean, like this is the most successful platform of our age, the smartphone. And what I find fascinating is that software developers start developing something, say an inventory system for, for whatever, and they're using the smartphone as a barcode scanner and for location and so forth. And they are actually developing a physical device, but they think they're writing an app. And I think a good platform abstracts the hardware so far away, but that also means that you have like so many aspects that need to be baked into the platform, like security aspects, reliability, um, uh, whatever it is. I mean, like and this is actually there's a great diagram in the Industrial DevOps book which shows like all these entities that should be part of your platform, so that when you develop the product, you do not have to think about that. If you are installing a smartphone app, you're not worried about security, because you know it's running in its sandbox, and the platform is so built from the ground up with security in mind that you don't have to reinvent that. And so when you were saying platform, I think there are multiple definitions. But that's what I meant, that you really spend the energy to have a platform. And I think this is something, for example, Volkswagen is investing into building their automotive platform. And um, Volkswagen's platforms gives them a new car every 40 months, while BYD is at 18 months. And according to you, they could be at a week or even a day. And so the question um, is this platform thought a dead end, or how do you get to a really good platform? Do you differentiate product development versus platform development? That is where my question about architecture and platform was going.
Well, let me see if I follow well enough to add value. I love the idea. Let's see if I followed it well enough. I think part of what you said is the advantage is that security is um, thought about carefully and thoroughly. Maybe carefully is not even the right word here, but thoroughly. There's thorough security. And maybe some types of efficiency are important depending on what type of solution we're providing, like especially in battery packs and heating and cooling systems and power development systems, the efficiency is incredibly important. So maybe the efficiency is thoroughly analyzed. Well, with enough compute, which some of these modern companies have more compute than the world had 8 years ago. I mean, it's pretty different, right? Per company, you have more compute than the world had 8 years ago. With enough compute, we can analyze a new version of a thing for security, for efficiency, for cost of manufacture, for ease of maintenance in a shorter and shorter and shorter amount of time. An interesting mental jump to make is the time it takes to validate something has zero correlation with the quality of that validation. The quality of that validation is the only thing that correlates with the quality of the validation. We can have a really long running test that has very low security value add. And we can have an essentially instant test that has a very high security value add. So what I'm experiencing when I'm working with companies like Tesla and SpaceX, is the number of automated tests that run every second are in the millions. And those tests are AI enabled, but I don't mean to use AI like just a buzzword. I'm simply saying it's not the same test every time. They adapt and explore, which Google has written about more than 10 years ago. I love the book, How Google Tests Software. I think it's 15 years ago now, where the tests should adapt. They should mutate. And with AI, that's much more effective than it ever was before. So if you have more than 1 million tests that never stop running, and they're analyzing manufacturability, repairability of the CAD as it's being drawn, and the parts as they're being manufactured, the idea of taking the additional effort to design a platform, I think, is less valuable than it was before. But
Actually, if I may interrupt you there, because I think what I'm seeing a lot is something that you talk about a lot, and that is the stability of the interfaces, which is like talking about security. If you can stop security at the interfaces and there's no way to bypass it, it's exactly the same what you're saying about, the wheel will always fit even if the wheel team is independent from the suspension team. And so I think again, like as so often, it's a question about terminology, and it's yeah. Anyway, so I think we're on the same wavelength here.
I completely agree. The maintenance and backwards compatibility, even if we could design an excellently robust, efficient, highly secure system from scratch instantaneously, even if we could, and we're getting closer and closer to that every day, even if we could, the maintainability, the backwards compatibility, and then the overall lifecycle affordability still can't be there without backwards compatible interfaces. Yeah.
Yeah, actually, this is an interesting topic, which again, like going off on a tangent here, but I had a number of really interesting conversations about semantic versioning on hardware. I did like a study with Tier 1 and, Martin Eigner. He's also fairly well known here in Germany. He actually, it was very interesting. He gave a keynote at an event here locally, and there were like 150 people in the audience. He was asking like, well, who's even aware of semantic versioning? And out of like 150 people, 3 hands went up. Do you have what are your thoughts on semantic versioning for hardware interfaces?
Well, let's see if I know. I might not be one of the people to raise my hand. So I would think it's where we have human readable names for interface collections.
It's more about having different version numbers that tell you whether you're implementing a bug fix, whether you're adding functionality, or whether you are introducing an incompatibility. And this is an issue, I think, if you have many, many dependencies. So a classical example could be if you change the material of a windshield wiper, that doesn't change the functionality, but maybe makes it like a little bit durable. That may be a patch fix that doesn't change anything. But if your window wiper system suddenly says, well, in addition to just regular and interval, we also do like dirtiness detection. You add a functionality without breaking backward compatibility, and that concept would give you, like in software development, the ability to make sure that you're not accidentally breaking any dependencies.
I love the idea of adding features, maintaining backwards compatibility, and not breaking any dependencies. Naming the change to help keep that in mind, I'm sure can only help.
It's not just about naming, it's about basically using a numeric scheme like 1.2.3. And so that's why you can use model checking to make sure that you're not accidentally putting something into your system that is incompatible.
Okay.
It works really well in
Okay.
software. Like if you're do you remember like that log4j bug where suddenly everybody realized that this library that does logging had a bug, And basically, by simply putting in your dependency file that lists all the libraries that you're using, you could be sure that none of the libraries that you were using were in turn using other libraries and basically accidentally pulling that incorrect library in. Anyway, I'm going off on a tangent here, but
No, I love it. You're making the point very clear, Michael.
yeah,
I love it. No, that was what I would hope you would, that's exactly what I would have hoped you would say. That was fantastic for me.
what I find
I
interesting
completely agree with the value of it too, if I understand you.
What I find interesting about what I've seen in your talks on architecture is that you keep the number of modules and thereby the number of interfaces really low. And so
I aim for 10.
if you have like less than a dozen modules, then I do not think you need a mechanism like that. But if you, okay, that's interesting.
Well, the idea is that to minimize the cognitive complexity, the difficulty to think about it,
Mhm.
right? Humans are still very much in the loop for engineering. Now, a year from now, that might be a little different. 3 years from now, it might be significantly different. But right now, there is huge speed, pardon me, there's huge speed advantage if humans can think about the whole system at once. So having around 10 modules seems to make it dramatically easier for humans to comprehend the whole rocket, the whole airplane, the whole missile, the whole car, the whole charging system. So, and modules, of course, can have submodules. As long as the humans understand all, for example, 10 of the big modules and their APIs, their interfaces, then they can be right now deep in one of them, which might have submodules, maybe 10 submodules. For example, the battery pack absolutely has 10 submodules. So then you can get deep in the battery pack. And that seems to let humans grasp not only the intricacies of whatever they're working on now, but then also its place in the ecosystem of the whole product.
Hmm.
There's something I got worried about when I tried to understand semantic versioning just then, and I may be misunderstanding and mischaracterizing it. Tests, the only robust test, hard to fool test, are tests that are, if we're testing for security, checking that something has a version number to know if it's this type of thing or that type of thing is a channel for error,
Yeah.
right? What if it's been mislabeled or maliciously mislabeled? So instead, we always test something as if it's unknown and build up from our tests. Do we understand what it is? And then does it behave the way something of that type should?
Hmm.
Period. End of sentence. No matter what it's named. So if a new module gets connected to a car, well, this starts an important topic, emergent architecture.
Yeah.
So most car companies around the world, they define what all the around 10,000 parts of the car are going to be well before mass production. So the car is never surprised by parts that were never intended to be there being there, or that's the goal, for the car to never be surprised. When I worked in Tesla, we would be designing new types of parts, new concepts, like switching from resistive heating to heat pump heating and cooling, which then also connects to the heating and cooling of the battery pack. So very different type of system. And the other parts of that car were designed and thought of before, when no one had ever even thought of having an octo valve shuttling warm and cool fluid out of the battery pack to then warm and cool the seats and the cabin. So all Teslas were running software that's now named Tesla One, which is constantly asking, what is connected to me? What is it? And it's investigating it all the time. And those cars are perfectly happy finding parts that they had no idea about.
Hmm.
As long as they pass all the security handshakes, and as long as they have an API that the car can begin to understand, it's fine to have modules that were never even thought of when the other modules were designed and built.
Yeah.
And that's the only way to have a high innovative system. Like the internet, of course, it didn't have a master list of every computer and phone and watch that'll be connected to it when the internet protocol was first created. Instead, a handshake, a way to announce yourself as a new
Yeah.
thing connected to the internet, was authored. And that's still used, even though many of the servers that connect now and watches and phones can do a lot more. They say, hi, TCP/IP, hi, DNS. I am a thing that can connect to the internet, and I can do these other cool things that maybe you've never heard of before. Well, cars, rockets, airplanes have to be built the same way. And the idea, which maybe I misunderstood, that a naming convention written before would determine maybe how we would test or how something would be used, to me feels brittle, but I might be misunderstanding.
I think so. And I think I'll send you something on the concept afterwards. The way I see it, it's part of the machine readable documentation that for software components allows the build process to assemble the bill of materials in quotes to find compatible versions of software modules to work together. Because with dependencies and dependencies of dependencies, often using the same libraries, you can then decide, well, this library exists in version 1.5 and 1.6, but because this module needs 1.6 and the other one 1.5, well, of course, I'm going to pick 1.6. That's kind of what it's doing. And the other thing is, and I think this is actually even more important, I mean, it's not supposed to replace testing. It helps you with automatic assembly. And there is, of course, danger of relying on something like that. You still need your tests on all levels. You need your unit tests, you need integration tests, you need to acceptance tests. Without that, it will not work. There's another aspect which I think you're probably very aware of, and that is the danger of tools. Because I've seen that with requirements management tools, because they, in my mind, are incredibly powerful and they are abused. And the reason why we have tens of thousands of requirements, because we can. And so, yeah, I mean, I think the semantic versioning, I think it definitely has its place, but it also has the risk of it being abused. And just so you know, I really want to respect your time here. I'm not sure whether you have time for after half the hour or not, but this is actually talking about app use. Um, and like another question that I had on my backlog here, like uh, what are the fake versions of agile hardware? How are people abusing the concept when saying, yeah, we are agile, but we are not? So this all goes hand in hand.
Wow. Wow. Well, also a meaty topic. But I'd like to process what I thought I just heard more about semantic versioning.
Hmm.
Is it possible to apply semantic versioning, labeling to apply which dependency needs to be referenced or not? Is it possible to apply semantic versioning programmatically?
Oh
So
yes,
you can have
absolutely. Yeah, that's
then it
what's being done. Yes.
matches the world that I cared about, right? Where
Hmm.
you investigate something without assuming it's anything, just
Yeah.
assuming you don't know assuming it's malicious, and investigate it. But then if semantic versioning is part of what's left behind, part of the metadata of that
Yeah.
analysis, then it matches, as far as I can think now, my use case as well. So
Hmm.
we're set. We're
Yeah.
we're whole.
Oh, thank God.
Um,
Yeah, but
you're
you know,
great, Michael.
sometimes a good debate is also fun. So.
Agreed. Oh, man. And I need more of those. That's one of the reasons I was really thrilled when you contacted me, is you reminded me, honestly, of what a thoughtful and how do I want to, pleasant debate partner you would be. I've been looking forward to this conversation for a few weeks now. Thank you so much, Michael.
Thank you.
My pleasure, absolutely. Then about fake agile, if any system is incompatible with designing, building, testing, and deploying faster than the way we're doing it now, it's not moving in the right direction no matter what it's called. And if it's not capable of designing, building, testing, and deploying legally, safely, robustly, faster than companies in China, you've already lost. And Scaled Agile Framework is the best known example of that. It is faster than what a lot of companies are using now, but they'll never compete with Geely with that. They'll never compete with BYD with that. They won't even compete with some of their existing suppliers in Hungary and Romania and the Czech Republic with that. And if they push it down on those suppliers, it'll only slow them down. And it doesn't mean that I think it's not valuable. In fact, I think it might be a very useful stepping stone. But it will have to be jettisoned. It will have to be torn out and thrown away entirely to gain more speed. So if companies are brave enough, they should skip it entirely. But most CEOs have been commissioned by the board of investors, basically, to not make too big a change in the company. So even at the CEO level, in most big companies all around the world, they don't have authority. They'd be impeached by their board if they moved much more radically. So for them, the only accessible move, which will be better than what most of them have now, is the Scaled Agile Framework. So it's popular for that reason, and I think correctly so. Then the question is, will board members understand the level of structural change, reporting change, removal of Sloan silos, company restructuring to project-based structures where you have head of products, which a lot of these companies did before in like World War II and just after, where you had heads of product. We would call them chief engineers or large project managers or large project leaders. Those were really popular before Sloan silos. So this has happened before. Some board members remember those. Bringing those back, if board members allow their executive teams to make that level of change, moving back to large project leaders and away from heads of accounting, heads of front-end software, heads of back-end software, they can save the company. And then of course they would move right past Scaled Agile Framework, right past SAFe, because you wouldn't need release train engineers to be mapping dependencies across trains anymore. Instead, you would have products. And those products are composed of designs that don't wait, whether we call them platforms or whether we call them modules, designs that don't wait. So the fake agile would be anything that's not enabling design, build, test, and deploy faster than the Chinese.
Well said. Yeah, and I mean, safe. I've definitely seen that conflict before. This is this I've seen safe being used right, but it's very easy to abuse. So that was like a good comment. To close up, I really want to have the readers or listeners with something tangible. So can you recommend, like, for any company that is traditional and does hardware, what kind of small real experiment would you recommend to do like in 30 days? And I think 30 days, I really like that time frame for organizations because it's long enough to see change and it's short enough for decision makers to take the risk of trying something.
Well, Michael, I'll take your bait, but I'll ask you to answer the same question because I think you've thought about this before, and I'm really interested to hear what you're going to say.
Yeah.
I would ask the company, what is something that you completely make and test in-house? And some companies might say PowerPoint, like that's it, right? But maybe some of them actually do design, build, test, and deploy something totally end-to-end. Maybe they do. I'd say, can you create a team of everyone required to go end to end in that for 30 days and say yes to everything they say for 30 days and see if they can go end to end in an entire revolution of whatever that thing they make, an entire iteration in less than 30 days. But the constraint, I think, would have to be something that you make in-house. Otherwise, you're just asking the supplier.
Right.
Now, I'd like to hear your answer to that same question.
I love your answer because I mean it shows that you're so deep at heart a hardware person, and that's great. And but at the same time there are like so many different aspects to it. And so my approach is to really start to look at the value flow. That's my thing. And to get people interested, I usually like to start with a very specific problem. And I typically start my engagements with a workshop where we really analyze the problem and try to pick it apart and find out, okay, so can we measure it? And also figuring out, well, we know the effect, but where's the cause, which is often elsewhere. And where I very often see a disconnect is between engineering and business, or between delivery and engineering. So in those places where you have like different practices, and then the idea is to create an action plan to really pinpoint that. Um, there's a little bit more to it, and I can also send you something. But again, like looking at a value flow, measuring it, defining measures, and then after 30 days, measuring it again. So I feel value flow is my main tool for doing change. But at the end of the day, I think in 30 days, that's kind of bottom up. And I think bottom up is so important for showing people that you can change something. But then you also need, and that's why the question about leadership and strategy, you need also like top-down direction setting so that those small initiatives accumulate and move all in the right direction. So that's my answer to that question.
I love your answer to that question. And I suspect there are many project coalitions, leadership coalitions that need exactly that answer. So I'm glad you have that answer. I am at my time, but what a high point to conclude on. Michael, it is my honor. I look forward to seeing the final product. I'll say for people that want to contact me, I like social media. So LinkedIn, X is where I put the most deep thoughts. That just fits the X community that I've found. Instagram, but that's mostly food pictures. Then I did write a book called Scrum Master. And then I'm online at www.abi-agile.com, Agile Business Institute-agile.com. So you can find me there. And Michael, your book to be published by MIT Press, likely next year. Would you like to preview that for the listeners?
I think the listeners have read and seen already too much of that. So, but I will definitely put your links also in the final article, so you'll find Joe's links there. ABI, that's the Agile Business Institute. I think you're also part of the Scrum Alliance, correct? Yeah, I don't quite understand how they're connected, but again, like I will put enough pointers there and reach out to Joe. I have to say you're absolutely visionary. You're definitely to me at least, like in this space, the most visible person who's not just, making a living consulting with all these great companies, but also really making sure that this is being heard and that we learn how product development can look like.
Let's make the future the most exciting version of the future we can figure out. My honor, Michael. See you next time.
Awesome. Thank you, Joe.